In the case of a car spring, the spring on a pogo stick and the spring on a clicky pen, these springs all operate through a function of compression, which means the spring gets squeezed and squished. In the case of a garage door spring, this spring functions by stretching it. We call this an extension spring. Check out the springs in your garage that support your door. You're going to see one or two or both types of springs. Well, now that we have a new dimension to our conservation of energy expression, let's go ahead and add that. Now recall from the previous lesson that we defined the work done by a conservative force was equal to the negative of that potential energy. Or how we expressed it in the big cloud was that the potential energy of that conservative force was equal to the negative work done by that force. And that means that the work done is equal to the negative of the potential energy. So this was the big cloud from the previous lesson. We also recall that the conservation of energy from the previous lesson was described or defined as this right here. So if we experienced a negative change in potential energy, that was proportional to an increase in the kinetic energy. Well, this right here was at that point defined as gravitational potential energy, the only conservative force that we had yet to talk about that resulted in kinetic energy. Well, we have another one, and all we have to do now is add in the negative potential energy of a spring. So we are adding this term in to our conservation of energy. So as we break this up, let's go ahead and break it into our terms. We've got negative 1/2 kxf squared minus 1/2 kxi squared minus ma sub g yf minus ma sub g yi is equal to 1/2 mvf squared minus 1/2 mvi squared. Okay, so we've expanded all of our terms now. Okay, if I distribute this negative and get all of my initials over to this side, you'll see that we have, once we distribute the negative, all my initials will be positive. And by adding this over here, that'll be positive. And by distributing my negatives, all my finals will be negative. And so we'll get them all over to this side. By getting all my initials on the left and my finals on the right, I end up with this expression. 1/2 mvi squared plus ma sub g yi plus 1/2 kxi squared is equal to 1/2 mvf squared plus ma sub gyf plus 1/2 kxf squared. Okay, well, this is our new statement of conservation of energy right here. And you can see that we can further identify it as the sum of all of these energies right here is my initial total energy. And it is equal to all the energy after everything's been transferred. So we are once again showing that energy is conserved. Well, this term right here is our newest form of conservation of energy. And you will note that we haven't changed it at all. We've just simply accounted once again for a new type of conservative force.